Hello, good afternoon, sixth grade class. So this is how we're gonna have our video classes. We're gonna have one every week. So yes, hello. Who am I talking to here? Valeria Beatriz Garcia Diaz. I don't know your mother's name. I just know your name. So you have to write your name if you want to say hello. And so, fourth partial. We're gonna be talking about astronomy. First things that we're going to be talking about. So let's see, fourth partial. We will begin with astronomy. Hi, Jenny. Now I know. So let's open our books to page C82. Because these video classes are to explain the content before going to the quiz. Remember that you will have to make online quizzes. And these are the things that you already read and already summarized. And you already have questions for this. So I am expecting to have some of your questions so that I can answer them live on this YouTube live, which is going to last approximately 40 to 45 minutes. Okay, so on page C82, we have lesson 1, which is what is Earth's place in space? So it's important for you guys to have your notebooks and your books ready. This is like having class, so you have to be taking notes. The good thing about this is that you can rewind, you can go back on the video once it's finished. It's going to be always on the YouTube platform and on the school. And so this is having classes, people. And remember that we're going to be taking quizzes every week. Hello, Mia. Okay, so to answer this question, we need to understand a little bit about the universe. The first thing we have to know about the universe is that the universe is everything. Okay? It includes the very distant, the very far away, the stars and the galaxies and black holes and other galaxies, but it also includes the very small, our sizes, and even the smaller sizes up to the smallest. So the universe is everything. So basically it's pretty big, very, very big. And we don't know the size of the universe, but we know some things about the universe, that it's so big that we can consider, some have considered to be infinitely big. But others consider that it cannot be infinite. But, that's a debate, something that science doesn't know what is the actual size of the universe. But we know some things about the universe. We know that it's infinitely big. We know that it doesn't have a center, for example. Any place could be the center of the universe. And we know that did I say this already, that it is growing. So we don't know that on the biggest of the scales things about the universe, but we know some things about the smaller universe. For example, we know, let's say that this is the observable universe. Okay. And what is the observable universe? This is the universe that we can actually see. Because for us to see, we need light. And for light to travel very far distances to where we are here. Okay? It has to be the center. So over here. It has to be, light needs to travel very large distances because we only can see the light of the stars that are emitted. If there was no light, we couldn't see. As we all know during the night, that if we don't have any light, we cannot see. So this is the observable universe, the universe that we could actually see. But the real universe is larger than that. And we don't know how larger than that it is. We don't know. Okay? But the observable universe is pretty big. The observable universe contains millions of galaxies. Okay. So, what is a galaxy? Galaxies are groups of stars. Okay? Of how many stars? Of millions of stars. Okay? So, I'm going to make some galaxies over here. So, what I'm drawing right now are galaxies. Some are spiral, some are elliptical, but all of these are made of stars. All of these galaxies are made up of stars. Okay, I'm gonna do it faster because it's taking too long. So we have all of these groups of stars. Millions. Each of these little circles I am making contains millions of stars. And the observable universe has millions of galaxies. So you multiply millions times millions, you get, billions, I think, trillions. You get a lot. We have a lot. Okay, so since this is the observable universe, just because this is the observable universe, that means that we must be in the center of the observable universe. So I'm going to put us here, our galaxy. We're going to name it. You know the name of our galaxy? It's called the Milky Way galaxy. Okay? It's called the Milky Way galaxy. Now, let's look only to our galaxy. Let's look only to our galaxy. So if we take a close-up and look only to our galaxy, we will notice that our galaxy. So I'm going to explain right now what these spirals are. These spirals only represent stars, okay? It's not that the spirals are like that. So actually, let me make it a little bit better. More, if I can, more realistic. So actually, stars are grouped like this. We have more, of course, in between. It's like stars make these spirals. So if we look closer, we can see that some places have more stars than others. And this is what makes our galaxy be like a spiral, okay? In the center of the galaxy, there is a massive black hole. but we will talk about galaxies and black holes a little bit later. All of this is because I want to tell you that we know our place inside the galaxy. You can go to page C92, page C92, and you will look that we have that's an image of our galaxy and the position of the Earth inside our galaxy. Now, as we can see, our sun is just one of millions of stars in our galaxy. And let me tell you that the sun is moving around the galaxy also, because this galaxy is rotating. It's moving. It's like a wheel. It's like a disc. So our sun is moving as well as the other stars. Every star is going to be moving, okay? Every star is moving, and this is a very long cycle. It takes about, I'm not sure how much it takes, like, let me see. It takes about 30,000 years. Yeah, it takes about 30,000 years to travel from the center of the galaxy. No, so it's not how much time. It doesn't say here. I'm gonna look at it a little bit later, but it's a really long time. It's in the thousands of years. Okay, so this is the sun. We are over here. You are over here. Now let's look a little bit closer to this only. So we are zooming in. Every time we're zooming a little bit in. Okay, now let's look at our sun only. So our sun is a star, if you didn't know. It's a star like all of the others that we see at night. Actually, at night, we don't only look at individual stars, we are also looking at different galaxies. But because they are so far away, they only look like one point. Okay, so this is our sun. It's pretty big. And so let me make it a little bit bigger. But if I'm gonna make it like this, maybe, okay. So something that we need to know is that this is the only star in our solar system. We only have one star in the solar system. We have other things in a solar system, for example, planets, asteroids, and comets, and dust, for example. Okay, around the sun, the sun is the center of gravity for everything. So that means that all of the things in the solar system are kept together by the sun. And in order, the planets and different things are like this. The order of the planets and different things are like this. The closest planet to the sun is Mercury. Mercury is the closest planet to the sun. And I'm going to make the orbit of Mercury. Okay. So that in this way we can see that Mercury is like the fastest of the planets. Now, we also have the planet next after Mercury, we have the planet Venus and the orbit of Venus. After Venus, we have our planet Earth. Okay? So this is our planet Earth. We are here. And after our planet, we have planet Mars. So this is our neighbor, planet Mars. After Mars, something happens. There is a chain of asteroids, okay? And what are asteroids? Are rocks. very big or small rocks. And this is our asteroid belt. So these 4 planets, Mercury, Venus, the Earth, and Mars, are rocky planets. They are solid planets. They are smaller planets than the others, but we are more solid than the other planets. After these 4 planets that we're going to be called the inner planets or the rocky planets, we have the gas giants. Okay, so let me label this the inner planets, or the rocky planets. Why rocky? Because we are solid. These planets are made of rock. And remember that this is the sun. Let's make some. Well, actually, the sun is more a circle, so it's better if we keep it a circle, a sphere. Yeah. Okay. Then we have the asteroid belt, as we mentioned before. So let's label this the asteroid belt. And after the asteroid belt comes the bigger planets, the gas giants. Okay. And let's begin with the largest of the planets. After the asteroid belt, we have the largest of the planets, which is Jupiter. Okay. And we can see that the orbits are getting bigger and bigger, right? Obviously, the farther away you are from the sun, the orbit is getting larger, and that means that more time passes. Okay, for a planet to make a complete turn around the sun, more time passes. By the way, let me remind you that all the planets have the same direction of their revolutions. Okay, they are all revolving in the same direction. All the planets are moving in the same direction. Okay, so this one's Jupiter. Remember that. Do you have that in the book? It's our first image. Now, afterwards, we have a very famous planet. Why famous? Because it has very large rings. Well, it's not as big as Jupiter, but it's pretty cool because it has like these rings that you can look through a telescope. And this planet also has an even larger orbit than does Jupiter. Now we have the final 2 planets are also gas giants, which are Uranus So we have Uranus over here. And the final of the planets is Neptune, another gas giant. So, and these are what we call the outer planets. Or gas giants. Why gas? Because they are mostly made of gas. They are mostly made of atmosphere more than rock. On the other hand, the rocky planets have more rock than atmosphere. These ones have less rock and or even less liquid than atmosphere. Okay. Some motions that, so this is our place. This is where we are. Remember all that we have seen before from the observable universe to the Milky Way galaxy to the solar system to planet Earth. This is where we are. So this answered the questions, what is Earth's place in space? Now, there are other things that we need to know about Earth's place in space. We need to understand the movements of Earth. The movement of any planet around its sun, it's called a revolution. So this is an orbit, and the orbit is the path that it makes in a revolution. Okay? So as you can see, the orbit of the planet is not a circle, it's more like an ellipse. It's an ellipse. Hello, Legding. Okay. So this is what we call a revolution. Okay? A complete orbit around the sun is a revolution. And for planet Earth, how much time does it take to make one revolution? The answer is 1 year. So 1 year is equal to one revolution in Earth, in planet Earth. One revolution. 1 year, one revolution. One year, one revolution. Okay? So this is a year. So if you were born today and the Earth is over here, in 1 year, the Earth is going to make one complete revolution around the sun. So every time that you celebrate your birthday means that you are making a complete turn around the sun. Happy birthday to everybody, because 1 year ago we were here, but not one less turn around the sun. Okay, so that is our first movement, revolution. Now let's go to our second movement, which is the movement that gives us day and night. So our first movement, we said that was movements of the Earth. We said that it's called revolution, and that it takes 1 year. Now the second movement is called rotation. And I want you to tell me, I'm gonna give you 1 minute to ask yourself, and maybe if you can write on the comments, how much does it take for one rotation to happen? I'll be right back. If you write on the comments correctly, I will give you 1 golden point. The first person. Hello, I'm back. Yes, Jenny, you got the point correct. One rotation takes 1 day or 24 hours. Exactly. 1 day, which is the same as 24 hours. Just as 1 year is equal to 365 point and 365 and 1/4 days. Okay. So here I brought planet Earth here. You know, this is a scale of planet Earth. And where are we? We are here, Honduras. Over here. Here we are. So as we can see, we're a little bit north of the equator. By the way, we can. It doesn't matter in which direction we see the Earth. It's still the Earth. And which side is north? Up or down? In this way, north is down. So, but we are usually more accustomed to look at the Earth in this way. And here is the way that Earth rotates. And the direction of rotation is this one. Okay? So it takes 24 hours, just like Jenny said, 1 day to make a complete turn. And what is day and night? So imagine my shirt is the night, and we can see like there's a little bit of shadow over here. And the sun is over there. Okay, let me make a sun over here. It's gonna be way larger, right? Obviously. As you can see, when the sun, let's say we are here, Honduras, yes. So right now, we are in the direction of the sun. And when it is night, we are, well, normally every second, the Earth is moving very slowly. Very, very slowly. When we are in this direction and the sun is over there, we are having, this is what we call dusk. This is what we call when the day is ending. 6 p.m. almost, and then we enter the night. No, but it's in the other direction actually. So right now, which is almost 2 o'clock, it's in this way. And we are turning, and when we are over here, it's 12 in the noon, in the night. Okay? This is night. As you can see, there's a shadow on this part, and the other part has day. That is why when on one hemisphere, it is the night, on the other hemisphere, it is the day. And as we go back to the sun, we eventually get the day into daylight, which is called dawn. Okay, and that's it. This is the movement of the Earth forever and ever. And as it is moving in this way, it is also moving around the sun. So we have these two movements, basic movements. Now, we have to learn a little bit more about the movements of the sun. Yeah, the movements of the sun, movements of the Earth. Because the movements of the Earth have a lot of impact on the Earth itself. Well, one of the impacts is day and night, which is caused by the movement of rotation. Now, the movement of revolution causes other things. If you can go to page C84, we will see what happens with this in this rotation of the Earth. If we have the sun, well, we have the sun in the center. We orbit around the sun. So this is the sun. And have you noticed that the Earth also has an angle? Is in an angle? This angle is very important. This angle is going to cause different things. So if we were to analyze the orbit of the Earth like this, you have to be creative here because we don't have a 3D image right now. So if the Earth has an angle, and this angle is like this. So this is the angle of rotation. That means that it will be rotating in this direction. Let me put it in another color. So this is our planet Earth. And this is just the angle of rotation, okay? And this divides the world into hemispheres, right? And let me divide our world. So we have the northern hemisphere and we have the southern hemisphere. And when the Earth is in this point of space, closer to the sun, this is well, actually, let me see. Yes, this is in what we call summer. Why summer? Summer on the northern hemisphere, but it is winter on the southern hemisphere. Why? If you look at the sun's rays, where they are hitting more the northern hemisphere than the southern hemisphere. The southern hemisphere doesn't get a lot of sunlight even during the day. Look, this part barely gets sunlight. So that is why it is winter on the southern hemisphere and it is summer on the northern hemisphere. Right now, the Earth is actually a little bit on the other side. And well, so that's going to be the last one that we're going to see. After summer comes fall. And this is our angle. And we have to imagine that this is north, this is south, that the rays of the sun are hitting in this direction. So in fall, the northern hemisphere is getting a little bit less sunlight than it did in winter, and the southern hemisphere is getting also a little bit more sunlight. So on the northern hemisphere, it's going to be fall or autumn. And on the southern hemisphere, it's going to be spring. Why spring? Because they are coming from a winter. And if they're getting a little bit more sunlight, then they pass to the next period, which is spring. But on the other hand, on the northern hemisphere, we are passing from summer. Remember that we are on the northern hemisphere. We are passing from summer to autumn. Why? Because we are getting a little bit less sun than we did over here. And the Earth is moving, obviously. Now, another 3 months pass, and we are on the other side. But always, if you notice, we are keeping the same angle. The Earth does not change the angle. The angle remains the same. So now we have always north and south. And we have the sun rays. And if you look now, which hemisphere receives more sunlight? The north or the south? Look, actually, the southern hemisphere is receiving more sunlight than the northern hemisphere. So now we have summer on the southern hemisphere, and the northern hemisphere doesn't get a lot of light, of sunlight. So that means that they are having a winter. Mm. Everything is making sense now. Now, so let me put the orbit again because we're. So now we have to imagine that we are on the other side. Let me make the orbit a little bit farther then. So if the orbit over here. Uh-huh. And now, how big is this? Here, better. Now, northern hemisphere, southern hemisphere. But that this doesn't look good. It's like this. Thank you. Yes. Okay, north and south. And now, as we can see, the sun, the northern and southern hemisphere are almost receiving the same amount of light, but the northern hemisphere is receiving more light than it did in winter. So on the northern hemisphere, we have fall. I mean spring, and this is what we are having right now. We don't feel it so much because we live in the tropics, and as you notice, in the tropics there is always sunlight. Here in tropical countries, we always have sunlight. You have to go near the poles, like places like Europe, Northern Asia, the United States, or places very in the south, like Antarctica, to get freezing temperatures of snow. So we have a question here with Jenny. What happens, misters, if all the world has the same season at the same time? Well, let me finish here. So if it's spring here, it has to be fall on the other time. Fall and or autumn. That's the same thing. To answer your question, Jenny, it is impossible for all the world to have the same season at the same time, and that is because of this angle. Let me show you how it would be possible to have all the seasons at the same time. So let me show you. Because of this angle that we saw before, Earth, the northern hemisphere has a different season from the southern hemisphere, and the seasons are changing forever. You know, it's a cycle. But what would happen? How could we get a planet Earth without seasons or without a change in season? If the angle of the Earth was perpendicular to the sun, see what would happen. That is a very good question, Jenny. If the angle of the Earth was perpendicular to our direction to the sun, then the amount of sunlight would be the same here. The amount of sunlight the amount of sunlight in this direction would be the same. The amount of sunlight would be the same, and the amount of sunlight, I always make this one bigger. The amount of sunlight would be the same. So you will see that the poles will always have less sunlight, but it wouldn't change. So Jenny, to answer your question, we cannot have the same seasons because Earth is really at an angle. It is not straight. If Earth was like this, there would be no change of seasons throughout the year. I hope that you understand this, and because this is not possible. Okay, so we have lectin, what the solar. Well, I need you to correct that question. Okay, people, we're almost finishing our time, so we have to end with the cycles of the moon and some interactions with the moon and the sun. So, cycles of the moon. Just as the Earth makes revolutions around the sun, the moon makes revolutions around the Earth. Why? Because Earth also has gravity, and the moon is attached to the gravity of the Earth. So, if we look at the Earth and we look at the moon, we have to consider the position of the sun. So I'm going to make this Earth more over here. The sun is going to be in this direction. Okay, so if the sun, so remember that this is day and this is night. So on this side you have the day because you have the sunlight, and on the other side it is night. So let me make some sun rays over here. Okay, so when we can look at the sun, I mean at the moon, when it is getting sunlight, and we can see the moon sometimes during the day and sometimes only during the night, and sometimes we don't see it at all. It is because, as we can see, this is a good image that we have here on page C85, very explanatory. So what's really happening, you have to imagine that this is the Earth, and well, I forgot something very important, right? The angle, mister, come on. So yes, our angle of the Earth, there we go. But nevertheless, this is going to be night and this is going to be day, right? So it doesn't, as you can see, the angle doesn't matter if it's day or night. Now, if we can see at the moon completely, that means that we have a full moon. Okay? So we have to look at the moon completely. But what happens when the moon is over here? Well, in this side, the moon also has day and night. It also has a dark side and a light side. Okay? So how is it going to be over here, mister? Okay, the same people. When the moon is in this direction, you can only see, wherever you are, you can only see the moon like this. This is why we have a half moon sometimes. And what happens when the moon is over here? Well, the same. You cannot look at the moon in the day because when it is day, you cannot look at the moon in the night because when you are here in the night, the moon is on the other side. So if you want to look at the moon, you have to look at it in the day. But because the sun is so powerful, it's difficult to look at it because the sun has so much light that you cannot see the reflection of the moon. By the way, the moon does not give light. It can only reflect the light of the sun. So that's why we cannot look at the moon during the day, except very early in the morning or very late in the day, in the afternoon, when the sun's light, we are receiving less sunlight when we are passing to the night. So this is what happens, people. And then the moon makes its orbit, and the same thing. You cannot look at the moon during when it is over here. This is what we call a new moon. That you cannot look at the moon. And you have to look at it during the day. When the moon is over here, we have the opposite. No, sorry. Here. So we are looking at the other side. And when the moon is over here, we can start looking at it again. So these are the cycles of the moon. It's not that the moon is changing, it's just what we can see from the moon. The rest of the day would be possible. Mister, is that when we are at night in the rest of the day would be possible? Okay. The rest of the day is the other side of the world. When this side is at the day, the other side is at night. And this side is in the afternoon, and this one is in the dawn. Okay? So these are the phases of the moon. And now, to explain eclipses, sometimes we have two types of eclipses. We have the first and most common eclipse is called the lunar eclipse. And I hope that you saw the videos. You have to see the videos, people. And you also have to read the material. So a lunar eclipse is when the moon is exactly behind the earth. And what happens? That we don't have any sun rays coming in this direction. And you know what happens when something is blocking the sun, right? You get a shadow. So you have a shadow of the earth blocking the sun. But the color of the moon is not black. It gets like a color red. Interesting, right? Now, so this is a lunar eclipse. They are more common, as you can see. You can look at it from many parts of, well, this is not a good color to use. So, as you can see, so this is a shadow of the earth on the moon. This is a lunar eclipse, and if you are in any part of the world, then you can look at it. Now, let's go to the less common type of eclipse. And with this, I end the class. Solar eclipses. Now, sometimes it happens that the moon is in a position that is going to block the light of the sun that is coming to the earth. And this also creates a shadow. So let me make some continents here so that so this is a continent, people. Okay, so we have a continent here. So what's going to happen in a solar eclipse? The moon gets between the light of the sun and the earth. So now it is the moon that is creating the shadow. But as you can see, the shadow is only created exactly in one place. So if you want to see a total solar eclipse, you can only look at the total solar eclipse from one place and for a certain amount of time, because the moon is always moving. The earth is always moving. So that the total solar eclipse only takes a brief amount of time. And you will probably only have one opportunity in your lifetime to look at a total solar eclipse. I already had my opportunity when I was a kid. Now you will have your opportunity. We have to find out. You can look for in the internet when is in Honduras, when is going to be the next total solar eclipse. 2 years ago, yes, or some years ago, three, we had a partial solar eclipse. And what is the difference? If we look at the sun with our eyes, we shouldn't be looking at the sun with our eyes. We have to use special goggles. But if you were to look at the sun, you know, the sun is pretty intense. The light, it can burn our eyes. So we have to use special goggles, or we can make a video of the sun and then look at the video. That's a good idea. If you make a video of the sun without looking at it, you know, without looking at the sun, or you can actually even look at the sun through your cell phone, and you can make a video of the sun. Now, the thing is, when we have a solar eclipse, something strange is going to happen. Dun, dun. A little bit, minute by minute, second by second, you will see a little bit more of the shadow of the moon. Little by little, you are getting less and less sun, and this happens during the day. Little by little, you get less and less sun during the day, until there is a moment for a few minutes that all the day becomes dark. And in this moment, you can see the corona of the sun, but only for a small amount of time, of minutes, and you cannot look at it with your eyes because you can go blind. You have to look by video or with a special lens. And then the corona disappears, and little by little, we begin to get a little bit more and more sun, because the eclipse is finishing. And now, so little by little, it's on the opposite direction. So it starts to fade away, the solar eclipse, and the sun goes back to normal. So ask your parents or your grandparents if they have seen a solar eclipse in their life. If they had the opportunity, they should have. If I saw it, why didn't they, right? We lived at about the same time. So let's see. I have another question. Mister, is that when at night, because the beams must be at the nighttime, and because it doesn't happen beforehand? I'm not understanding your question. Is that when we are at night and the rest of the day would be possible? Mister, because the themes must be at the right time, and because it doesn't happen beforehand. I'm sorry, Legdin, what the solar, I don't get it. I don't get your question. So this is it for the moment. So on the next class, we're going to be talking a little bit more about the sun and other things about the sun. We have a quiz soon, and I don't want to make it so the video is a little bit extended right now. So for the next, so the quiz is only going to come from what we saw right now here on this video class. The quiz is going to be tomorrow. So be ready. You can look for the quiz on the platform of Community School. It's just like you where you found this video. So have a good afternoon and see you next time.